Hello, and welcome to this Stearns webinar. Now I would like to introduce today's presenter, Brian Van Imeren. Brian is the Field Service Manager and Application Specialist at Stearns. Brian, welcome to today's event. And with that, I'll pass things along to you to get us started. Brian, go right ahead.
I am the Global Field Service Manager and Application Specialist at Stearns, managing an entire portfolio including a complete line of industrial AC and DC clutches and brakes, and solid-state motor start switches. In addition to offering pre-sale and post-sale application support, I've traveled to numerous sites globally to assist customers in product training, system troubleshooting, and technical consulting. So this will be our agenda for today. First, we'll take a look at torque requirements for assurance that the brake will efficiently stop and or hold the load, including full load motor torque, overhauling torque, average dynamic torque, and static torque calculations, followed by advice to better prepare for the thermal capacity required in rotational or linear load applications. Next, we will discuss the importance of understanding environmental and service conditions early in the brake selection process to ensure protection against corrosion and rust. We'll touch on power supply considerations, including confirming your brake is getting the proper voltage and has adequate current. We will walk through how to determine if a motor is compatible for use with a specific brake, as well as the need for standardized brake maintenance. Lastly, we will end with modifications or added features to consider if you require a brake for challenging or unique application environment. We will leave some time at the end for Q&A. Please leave those questions in the Q&A box, and we'll go through as many as we can at the end of the session. Starting off with the first common issue to avoid, the brake does not sufficiently stop and or hold the load. This is a common issue we hear customers run into and is often due to simply not calculating your brake torque requirement correctly. Brakes should be sized for the required loads and not significantly oversized. Oversizing a brake can cause problems, as does undersizing. There are several considerations for selecting the correct brake for a particular application. When a brake is being used as a holding brake, static torque should be considered because it is often measured as the breakaway torque, or the torque required to overcome the brake. Therefore, if you are using a brake to hold a particular load or hold the weight of the load, you'll want to configure the proper torque to ensure the load won't drift. Dynamic torque is the torque required to stop an inertial load and is approximately 80% of the static rating. This could be used in linear, rotating, overhauling, or overhung applications, as in the case of a hoist or winch. Calculating proper dynamic torque will guarantee that your brake will not only stop your load, but also stop your load in time to protect all of the equipment within your drive. Some of the calculations we will cover in this section are full load motor torque, overhauling torque, average dynamic torque, and static torque. Starting with full load motor torque, given the motor data, the standard formula for calculating nominal static torque is equal to 5,252 times the horsepower divided by the RPM of the motor, multiplied by the service factor, and this can vary depending on application requirements. The most common industrial AC motors are designated Class B, which develop nominal static torque with relatively low starting current. These motors are suitable for full voltage across the line starting and can typically develop 135 to 150% of full load torque during starting. At Stearns, we typically use a service factor of 1.4, meaning that our recommendation is that the torque rating of the brake be 140% of full load motor torque for NEMA B class motors. An electric motor brake is typically rated at 140% of full load motor torque. So the motor is not able to simply drive through the brake if the brake is not properly released. If the motor is held by the brake without rotation, the motor will demand locked rotor current, which will tend to make the motor thermal overload protection disconnect the motor and the brake from power in a timely manner, so to protect the motor and brake. Overhauling loads such as a hoist, lift, or elevator have two requirements: the braking torque required to stop the load and the torque required to hold the load at rest. The formula for calculating this is dynamic torque is equal to 0.158 times the weight of the load times the velocity of the descending load, represented in feet per minute, divided by the RPM of the motor. When we mention RPM of the motor, we're referring to the speed of the motor itself. In other words, if you're using a gearbox that will slow the speed of the output shaft, we're referring to the motor RPM before going into the gearbox. For oversized motors or unique performance requirements, size the brake by factors such as inertia or stop time. The following calculations are appropriate where there is high inertia in critical applications, as well as many overhauling load conditions that require both stopping and holding torque. In this first formula, total system inertia reflected to the brake is equal to total inertia of the brake itself plus inertia of the motor plus the equivalent load inertia reflected to the shaft going into the brake, where inertia is represented as pound-feet squared. The second formula deals with rotary conditions. Rotary could mean a rotating table, saw blade, or any application where the actual load movement is rotational. To calculate rotary motion, total system inertia reflected to the brake shaft is equal to total inertia of the rotating load times the shaft speed of the load divided by the shaft speed at the brake squared. Torque and power reduction can be significant in the case of vertical linear applications. The main purpose of a holding brake is to relieve the motor from maintaining the holding torque during standstill periods in vertical linear motion application. For linear applications, the total torque of the application will be zero during motor standstill, and the motor does not need to maintain holding torque. Therefore, a holding brake may not be necessary. The final decision to apply a brake should only be based on calculating the torque requirements. Total inertia reflected to the brake is equal to the total weight of the moving load times the linear velocity of the moving load as measured in feet per minute divided by 2 times pi times the speed of the motor shaft at the brake squared. Once the total system inertia is calculated, the required average dynamic braking torque can be calculated. Dynamic torque is equal to the total inertia reflected to the brake times the motor shaft speed at the brake divided by 308 times your stopping time. Once your dynamic torque has been calculated, static torque is simply 120% of whatever your dynamic torque is that you calculated. After determining the general type of brake for a particular system, sizing for optimal performance and long life are next on the agenda. Mistake number 2 is the brake was sized for torque, but thermal capacity was not considered. The brake should be set up to handle whatever load is applied to it. If you don't factor in thermal capacity, most likely you will have longer stop times and it will cause the brake to heat up a lot faster and therefore dramatically shorten the life of your brake. If a brake was not sized properly for an application, it may seem to perform well until it exceeds thermal capacity. One sign of failure is when it works for a while and then its stop or actuation time starts increasing. To avoid over-engineering and to meet thermal capacity, you can select a brake designed to provide inherent thermal capacity, add features like external fans and liquid cooling to increase the heat dissipation rate, and modify the system design to reduce the demands on the unit. To calculate thermal capacity, it is the total inertia reflected to the motor shaft at the brake times the shaft speed at the brake squared times the number of stops per minute divided by 3.2 times 10 to the sixth power. This is often overlooked where torque is considered and calculated and thermal capacity is not considered. It is important to determine whether or not the brake can handle the amount of heat generated by the energy the brake needs to stop. The third factor often overlooked is that the brake was not designed with water ingress protection in mind. It's important to consider the environment and make sure your brake will be equipped with the proper IP rating to overcome any contaminants that might affect its performance. When selecting a brake for any application, it's critical to take into account if the installation is exposed to fresh water or seawater. Marine, maritime, and Navy applications can include industrial environments with high humidity, moderate environmental contamination, outdoor installations exposed to weather, and coastal areas with moderate salt spray. Brakes used in maritime or Navy applications need to be customized to meet specific standards to ensure long product life. These standards provide various levels of protection against shock load and corrosion from seawater. Marine typically refers to freshwater applications, whereas maritime would be saltwater or sea applications. And Navy is referring to the U.S. Navy, who has specifications of their own. One example of a military specification can be on this slide, shown as Mil Spec B-16392C. The Navy sets certain standards to ensure product consistency. One example could be if there is a cast part in a system, the material must be ductile iron. Ductile iron is harder than cast iron and proves to be able to withstand their rigorous vibration testing. Other special modifications have to do with the type of material, corrosion protection, and types of coatings. Here we're showing a detailed breakdown of the ratings, enclosure finishes, and other featured hardware that has specific standards to last in harsh environments. An example of this under the maritime column, we note an alkali primer or zinc-rich primer is used as a base coat for saltwater applications where your standard water-based primer would not be sufficient. It's important to note that it is a best practice to talk to your brake manufacturer to ensure you're purchasing a properly rated brake along with modifications appropriate for the specific application. The fourth avoidable mistake is the brake enclosure was not specified for corrosive environments. The climate of a region can have a large impact on corrosive characteristics. Coastal areas affected by airborne salts and cold regions where de-icing and regular occurrence are examples of environments where special attention must be given to enclosure selection. The priority of the IP ratings is to protect the components inside the brake. Externally, stainless steel hardware and fasteners are equally as important as the proper sealing of the brake. Internally, you would want to inquire about the availability of stainless steel options for mechanical components, as well as brass in the disc pack. The bottom line is when it comes to protecting your sensitive equipment in severe conditions, check with the brake manufacturer for their recommendations on what level of protection is ideal for the environment in which your brake will function. Rust can be a serious problem for the longevity of braking system parts, and more importantly for your safety. We got a call that 8 gantry system brakes were locking up on a stacker reclaimer, and I was asked to come out and troubleshoot the issue. What I came to find out was they did not even purchase brakes with enclosures made for the outdoors. The brakes were mounted vertically above the motor. They had through shaft holes in every brake without seals, and what ended up happening was these IP23 indoor enclosures with holes in them filled up with water and rusted. The most common cause of rust in a system is prolonged exposure to water. Metals can also corrode when exposed to caustic vapors. Some materials are resistant to corrosion, while some are prone to corrosion. Brake manufacturers prevent corrosion with a few methods, including coatings, painting, plating, applying enamel on the surface, and using corrosion-resistant materials for enclosures and hardware elements. In addition to assuring your brake will have the proper IP rating, make sure to check with your brake manufacturer to find out what level of corrosion-resistant protection you require for your application. In the chart to the right are some examples of modifications that help protect against corrosion. Mistake number 5 is modifications to protect against ambient temperature extremes were not considered. In high heat ambient temperatures, you want to make sure you have the best friction disc and coil insulation available because the friction disc and coil are most adversely affected by heat. In frigid temperatures, you want to have the best gasket material to withstand the cold. And if there's fluctuation in temperatures, you definitely want to add a space heater to control condensation inside the brake. Check with the brake manufacturer to find out what options they have for prolonging the life of the brake in extreme temperature conditions. High and low ambient extremes alike can have adverse effects on the brake's performance and service life. For considering high heat extremes, let's look at the chart on the right. This graph is showing us the percentage of D rate of thermal capacity of friction discs based on the increases in ambient temperatures. For example, at 100 degrees Fahrenheit or 38°C, you'll see that your thermal capacity of your friction discs is derated by 10%. Coils, because they are electronic components, generate their own heat and have their own temperature rise. It's because of this you have to factor in the temperature rise of not only the coil itself, but also the temperature of the environment in which it operates. For example, let's say the coil temperature rise is 200 degrees and it operates in an environment that is consistently 80 degrees. You need to take the 200 plus 80 and you've already exceeded the limit for Class B. Not to mention other factors like the brake is in direct sunlight all day and can increase the heat further. If you have concerns about whether or not a certain coil insulation will be sufficient in an environment, you may want to check with the manufacturer's specifications on temperature rise. Mistake number 6. The brake was not properly rated for the hazardous conditions in the environment. Hazardous locations are areas where flammable gases and vapors or combustible dusts exist in sufficient quantities to produce an explosion or fire. In hazardous locations, specially designed equipment and special installation techniques must be used to protect against the hazardous potential of these substances. It is possible to have a properly rated brake for a hazardous location, but improper installation. Not following UL guidelines, these mistakes can nullify the brake's hazardous location rating. The next few slides will be breaking down the area classifications that account for dangers presented by different types of explosive conditions and enables protective measures to be taken which account for both cost and safety. The National Electrical Code, or NEC, establishes area classifications based on divisions, classes, and groups, which are factors combined to define the hazardous conditions of a specific area. As shown below, the divisions defines the likelihood of hazardous material being present in a flammable concentration. Division 1 is the category for environments where ignitable concentrations of hazards exist under normal conditions or where the hazard is the result of frequent maintenance or repair work. The installation and conduit requirements for Division 1 are more stringent than for Division 2 locations. Division 2 are conditions where ignitable concentrations of hazards are normally in closed systems. It's important to note that IP40 and IP56 enclosure options should still be considered as water ingress protection may still be needed. The classes define the type of explosive or ignitable substances which are present in the atmosphere, whereas Class 1 is locations that may contain flammable gases or vapors in explosive or ignitable concentrations. An electric disc brake for Class 1 locations is built to not allow flame or spark to rupture the enclosure. Class 2 is for locations with combustible dusts. An electric disc brake for Class 2 must be enclosed to restrict the entry of ignitable dusts or exit of sparks or hot gases, which may cause the ignition of dust suspended in the air. The exterior surface temperature of the brake enclosure must be limited so that it can function at its maximum rated duty cycle without causing dehydration or carbonization of the dusts that are present. The groups are defined as the explosive characteristics of the air mixtures of gases, vapors, or dusts. Materials have been placed in groups based on their ignition temperatures and explosive properties. Class 1 gases and vapors are listed in 4 groups, A, B, C, and D, based in specific properties such as maximum explosive pressure and ignition temperature. Class 2 airborne dusts are listed in 3 groups, E, F, and G. The dust properties considered include thermal and electrical conductivity. The table in this slide provides examples of which materials and external surface temperatures actually make up specific groups. So I wanted to give you an example of a typical wiring diagram for a hazardous location brake and give you this pre-installation checklist. It's important to have the installation instructions from the manufacturer. You may get a brake already attached to a motor or already attached to some OEM equipment, but it may not be wired yet. So what you're going to see is a conduit elbow, a sealed conduit elbow with different color wires coming out. They're not going to be labeled. You're not going to have anything to tell you what to connect them to. So you really need the wiring diagram from the brake manufacturer. And then 3, you want to check with the UL rating requirements. One of the requirements UL places on both Division 1 and Division 2 hazardous location brakes is that each one has a thermal protection cutoff switch. I've talked to people out in the field oftentimes who told me that these things weren't even connected. Now, that right there will nullify your UL recognition, and it will nullify the hazardous location rating. So you want to make sure you have your installation instructions for the manufacturer, your wiring diagram, and that you're following all UL rating requirements. Mistake number 7, the power supply is not sufficient for the brake. I get calls from time to time from people who have experienced issues where the brake doesn't release electrically. It releases manually, but when they put power to the brake, it doesn't release. Or the brake releases and the motor's driving and they're running their operation, and then somehow in the middle of the operation, the brake unexpectedly engages as if power was removed. They check their panel, and the panel says that the brake is getting voltage. So the first thing I suggest is that you need to measure voltage at the brake connection. Confirm at that location where the power leads connect to the brake leads that you're getting full voltage. Now, there can be several reasons why either you're getting low voltage or inconsistent voltage, or voltage just cuts out, but some of them can be as simple as a bad connection, a broken wire, a sticky contactor. These can be reasons why you're getting inadequate voltage at the brake connection, and thus the brake is not getting power. Another thing you want to check is, does the power supply have adequate current? You need a certain amount of current for inrush to release the brake. You need a certain amount of current to keep the brake released and hold it released. So you need to check if you have adequate current. And then lastly, if voltage is being supplied, say, through a VFD, you're not going to be able to power the brake through the VFD. Most VFDs have a dedicated separate contactor, or they call it an auxiliary contactor, where if they run the motor off the VFD, they have to connect the brake to a dedicated separate contactor to assure that the brake is getting consistent voltage at a consistent frequency. Improper voltage to the brake can cause several issues which can ultimately destroy the brake. If the brake does not receive enough voltage, This can not only hinder the release of the brake, but can also cause the brake coil to overheat and fail in the example of an AC brake. Too much voltage can also be a problem, as it can cause the brake coil to rapidly overheat and fail. Another problem could be unregulated power or dirty power. If a system is powered by a generator without the protection of a transformer, this can cause voltage spikes and or brownouts, which can destroy a brake coil and ultimately destroy your brake. Mistake number 8. The AC or DC coil was wired incorrectly. AC brakes have dual voltage coils and or dual frequency coils, so be certain to wire the coil correctly per the manufacturer's instructions. And with DC coils, check to determine if the coil is polarity sensitive and assure that it's wired correctly. The table below shows an example of inrush and holding currents for various voltages. Inrush is typically the current needed to overcome the spring pressure that sets the brake and to overcome the brake air gap. So it takes more current at inrush to release the brake than simply to hold it released once it has been released. Understand that the voltage requirement can change depending on the frequency. In other words, if you have a 460 volt 60 hertz coil, the same coil will only require 380 volts at 50 hertz, unless of course you have a dual frequency coil. It's important to know and understand what rated coil you have in your brake to assure long life of the coil and long life of the brake. Mistake number 9. The motor was not checked for compatibility with the brake. Not all motors are designed to accept a brake. It's best to consult with the motor manufacturer on what motors they have available to pair with brakes. Most motor manufacturers offer a variety of brake motor packages. In the next few sections, we will be talking about different configurations for pairing brakes with motors. The majority of motor brakes are face-mounted brakes that typically mount to the accessory end of a motor. So you want to check with the motor manufacturer to assure that a motor can accept a brake. If there's not an accessory end mount, there are other options, which we'll talk about in the next few slides. If a motor is not equipped with a mounting face on the non-drive end, you can consider a double C-face coupler brake that will mount to the drive end of the motor. With this type of brake, the motor drive shaft will insert into the input side of the brake shaft, and the brake output shaft becomes the drive shaft. It's important to keep in mind that the double C-face coupler brakes are for inline applications only, meaning that the brake shaft only has single bearing support, and it cannot sustain the impact of an overhung or side load, such as a belt and pulley, chain and sprocket, or even a saw blade. The typical inline application would be between a motor and a gearbox. However, if you have an overhung or side load application, there is another option we can consider. A foot-mounted bearing-supported through-shaft brake was specifically designed for use with overhung loads. It has dual bearing support to enable the shaft to withstand the impact of an overhung or side load. As I'm sure you can see, it is important to consult with the motor manufacturer and brake manufacturer before purchasing components for your drive. Mistake number 10 is there is no standardized maintenance program. You can avoid costly downtime by implementing a preventive maintenance program for your brake system. Scheduled maintenance can help you avoid catastrophic failures and reduce unexpected downtime by monitoring the brake's changes over time. I'm often asked to provide recommendations for the frequency of maintenance inspections of the brake, and my honest answer is preventive maintenance is application specific. Considering that there are many variables that affect the wear and life of the brake, the decision mainly relies on the cycle rate of the brake. The higher the cycle rate, the faster the brake will wear and components will need to be replaced. If I'm pressed for advice, I would say start with at least a 6-month plan and possibly consider inspecting your brake at least once per year. As you can see here, these are the types of checks you would want to make in your maintenance inspection. The last mistake we will cover today, the brake does not give the desired control system feedback. What we're really talking about here is the decision to use or the lack of awareness of the switches that are available to send feedback from the brake. There are a variety of brake release status switches, brake disc wear switches, and thermal indicators that can be used to send critical feedback from your brake to your control system. You can always check with the brake manufacturer on their options for feedback switches. This slide provides an example of a jack-up rig application that not only operates in a harsh environment, but needed many modifications. Stern supplied a total of 54 brakes per jacking unit on a single jack-up rig. These brakes are used to dynamically stop and hold the platform in place even during severe storm conditions. I just wanted to briefly mention that our team is working to continuously improve our services to our customers as well as developing new and innovative products to efficiently meet the demands of the industries we serve. We'd love your feedback. Take a brief survey at the end of this webinar and be entered to win a $100 gift card from Amazon. I would like to take this time to thank you for attending today's webinar on selecting a motor brake that meets the requirements of an application. As I have reviewed, there are many guidelines to follow to ensure best fit performance and service life in the field. Stearns is the leading manufacturer of spring set motor brakes in North America, and with over 100 years experience and expertise in the industrial brake and clutch markets, we offer a comprehensive line of standard and special AC and DC industrial brakes and clutches, along with a local factory-trained sales force to work with your maintenance staff and plant engineers whenever needed. To learn more about us, please feel free to visit our website at www.stearnsbrakes.com.
Brian, thank you so much for that great presentation. We do have some questions that have come in from our attendees, so let's get right to those. So let's get to that first question. I'm starting a new project and don't have all the details worked out yet, but I know I am going to need 2 AC brake motors. What is the best method for acquiring the best package for our application?
If you're looking for a brake motor, the best place to start is with the motor manufacturer, as they can tell you what types of brake motor packages they offer. If you have any additional questions they can't answer on the brake, then I would check with the brake manufacturer. But the motor manufacturer is the best place to start, as they are pairing the brake with their motor to provide a complete package.
Okay, great. Thanks, Brian. Here's another question. We have old brakes and don't know which company manufactured them. How can we identify them in order to find comparable replacements?
A good place to start is with the motor data. Where is the brake mounted to the motor? Is it mounted on the non-drive end or the drive end? What is the motor frame size? What is the horsepower and RPM of the motor? Hopefully you still have a motor nameplate, but if not, you can take measurements off the mounting face. You can measure the bolt circle diameter, the register diameter, and the motor shaft diameter going into the brake, as well as the shaft length. What voltage is being supplied to the brake? How many friction discs does the brake have? Is the application indoor or outdoor? Are there obvious modifications such as switches, a space heater, or a brass disc pack? If you can take some photos and send them to your brake manufacturer, often we will know what you have just by seeing photos of the complete unit as well as photos of individual components.
All right, another question came in here. Are there any concerns with using brakes in Arctic climates where temperatures drop below negative 40 degrees Celsius? Can a brake even operate in such a cold environment?
In extreme cold or Arctic environments, you should consider the most robust components available. For example, consider at least a cast iron enclosure and any support castings as well. And if ductile iron is available, this is even better. If there's potential for fluctuating temperatures, warming and cooling, you will certainly need a space heater to minimize any condensation inside the brake. Brass components in the disc pack Any components that are offered in stainless steel, such as hardware and fasteners, select those over standard components. You should also consider a heavy-duty type friction disc if anything is available, including considering a carrier-style friction disc. A carrier ring style friction disc is a metal ring with friction material bonded to it. It's very robust and will be able to endure these cold temperatures. A Class H coil will have a more robust insulation, and it's also a good idea to consider adding sleeving to any of the wires. Consider using Viton gaskets and seals, as Viton is permitted for static use down to negative 54 degrees Celsius or negative 65 degrees Fahrenheit, whereas gaskets and seals made of nitrile or neoprene will begin to crack at negative 40 Celsius. Potential voltage line drops should also be considered. Considering a general rule that coils can typically operate at plus or minus 10% of their rated voltage, keep that in mind when selecting the voltage for your brake.
All right, thank you, Brian. Another question here. We have an outdoor application with a vertically mounted, totally enclosed fan-cooled motor. The brake is mounted below the motor to a fan guard adapter. The brake is supposed to be rated for IPs 56, but we are still having issues with water ingress. Is there anything we can do to solve this problem?
This can be a real dilemma because most face-mounted IP-rated brakes are rated as such when they are close coupled mounted directly to the motor face. Like in a C-face application, the brake C-face is mounted directly to the motor C-face. However, when mounted to a fan guard adapter, much of the brake face is open and exposed to the elements because the fan guard adapter doesn't provide a solid face. The brake is basically bolting to standoffs from the adapter. In most cases, the fan guard adapter also acts like a funnel, funneling water into the brake face register. There are several things that can be done to solve this issue, and again, it is always best practice to share this type of detail with the brake and motor manufacturer before you place an order for any drive components. If the brake face has an internal lead wire hole in the mounting face, this will need to be plugged, or just order the brake without a hole there. If the brake is supplied with a single lip seal where the motor shaft enters the brake, inquire about better alternatives for face applications. At Stearns, we developed an adapter plate that uses an O-ring at the C-face register and V-seals where the motor shaft enters the brake. And no problem if you didn't order one with your brake, because we have a sealed adapter kit available for field retrofit.
Okay, Brian, we have time for a few more. I have a brake that is working great, but the friction disc wears out faster than I think it should. Any suggestions?
There are several reasons why this could be occurring. If you are convinced that the brake was sized correctly for motor torque and the load considerations for torque and thermal capacity, there could be other factors at work. Check if there are any adjustments that could be made that will enable the brake to fully release if the discs are dragging when the brake should be released. This would typically be the brake's air gap setting, and if it's too low, then your brake may not fully be releasing. On another note, while we're discussing air gap, if the air gap is too large, this could also put undue stress on your coil. So it's best practice to assure that your brake is properly adjusted. Another possibility is if the brake was designed to be mounted horizontally, but is being used in a vertical application. Most brakes, especially those with multiple discs, need some type of spring support to keep gravity from causing the discs to drag when the brake should be released and the motor is driving. If this is the case, check with the brake manufacturer to inquire about field conversion kit to convert the brake to a vertical brake. You should also consider the possibility for errors that could have been made during installation. For example, with some brake designs, if the hub is not properly positioned, this can also cause premature wear of the friction discs. And lastly, I would consider cycle rate as the possibility that it just may be high enough to cause more rapid than usual disc wear. If this is the case, check with the brake manufacturer to inquire about a possible heavier duty friction disc or use carrier rings. At Stearns, we have a high inertia friction disc for some of our brake series that has increased the life of brakes in high cycling applications.
All right, Brian, we have time for one more. What is an air gap and why is it important?
By air gap, we are either referring to the gap between the magnet body and armature in an armature actuated style DC direct acting brake, or in the case of an AC solenoid actuated brake, we are talking about the solenoid air gap between the coil frame and the solenoid plunger. Either way, unless you have a self-adjusting brake, this gap will increase as the friction discs wear, and at some point will need to be adjusted back down to its original factory setting. As the larger the gap becomes, the harder the coil must work to try to release the brake. In the same respect, if the gap is set too low, then the brake may not fully release.
All right, Brian, thank you for that last answer. And we are going to wrap the webinar up right there. Brian Van Imeren, thank you so much for taking some time to be here with all of us today. And thank you to all of our audience members for being part of this webinar event. Take care, and we will talk with you soon.